All right, let's dive right into this, literally and figuratively. Imagine you are out in the open ocean on a massive vessel, and suddenly the unthinkable happens. The ship starts going down. Welcome to this explainer on the physics of panic and surviving a sinking ship. We are going to look at the absolute high-stakes reality of nautical disasters. And, to really understand exactly what happens when things go wrong at sea, we're going to use the most famous disaster of them all as our core example. Yep, the Titanic.
Now, we all kind of buy into this collective myth about nautical disasters, right? Think about the Titanic. It's the ultimate symbol of maritime arrogance, famously dubbed completely unsinkable. And when a ship like that actually does go down, the myth tells us that surviving is just, a roll of the dice, that making it out alive is pure luck. But the reality is completely different. Surviving nature's fury is definitely not about crossing your fingers. It's about physics. It's about procedural logic. The brutal truth here is that walking away from a sinking ship requires a really cold, hard understanding of the mechanics at play.
Section 1. The Myth of Luck. Survival versus Chance. So if you think making it to a lifeboat or surviving in that freezing water is just about being in the right place at the right time, well, you're putting yourself at a massive disadvantage before the ship even begins to tilt. The brutal truth is that survival depends entirely on understanding the mechanics of water displacement and temperature. Escaping a disaster like this is not magic, and it certainly isn't a lottery. It requires a concrete grasp of specific scientific mechanics. It's really not about who's the strongest or who bought the most expensive ticket. It's about who actually understands what the ocean water is doing to the ship and exactly what that freezing temperature is going to do to their body.
Section 2. Mechanics of water displacement. The physics of sinking. Okay, so water displacement is the physical mechanic that dictates whether a massive multi-ton steel structure floats like a feather or drops like a stone. Basically, it relies heavily on Archimedes' principle. An object in water is buoyed up by a force equal to the weight of the water it displaces. When a ship's hull is breached, water floods in, right? And it replaces the massive pockets of air that were keeping the vessel buoyant. To put that into terrifying perspective for you, water flooding into a large breached vessel can add tens of thousands of tons of dead weight in just a matter of minutes. The ship suddenly becomes way heavier than the water it's displacing, and gravity aggressively takes over. In those moments of total chaos, panic is your absolute worst enemy, but physics is your reality. Understanding this mechanic tells you how much time you have, how the ship is physically going to behave and tilt, and exactly why you need to move to higher ground immediately. It's literally the physics of panic unfolding right beneath your feet, and understanding it is step 1 of procedural logic.
Section 3. The biology of hypothermia. The body versus freezing.
The second you hit that freezing water, a pretty grim biological clock starts ticking. Step 1. The cold waves crashing around you actually increase the air density just above the surface. You can almost feel that heavy, freezing air suffocating your breaths. Then, step 2. Intense physical stress begins instantly, and this is largely because water conducts heat away from your body up to 25 times faster than air. Your body immediately realizes, it's losing heat exponentially faster than it can produce it. Which brings us to step 3, shivering triggers. Now, shivering isn't just a minor reaction to feeling a little chilly. It is an aggressive, involuntary physiological attempt by your muscles to generate heat through rapid contraction. In fact, intense shivering can burn hundreds of calories in just a fraction of an hour, all just trying to keep your vital organs functioning. Your biology is literally fighting the physics of the ocean to keep your core temperature up. It's fascinating, but honestly terrifying when you realize how quickly this exhausts your body's energy reserves.
So, with the physics of the ocean and the biology of the cold completely working against you, it brings us to the ultimate question. How do you actually survive? We've seen the terrifying reality of a massive ship losing its buoyancy, and we've walked through the brutal, ticking biological clock of freezing water. The tension is incredibly high, right? But we're about to pivot sharply from the absolute terror of the disaster to the empowering, actionable solution.
Section 4. The logic of survival. Replacing panic.
What I really want you to take away from this explainer is that understanding these physical and biological mechanics, it isn't just interesting trivia. It is the exact framework that saves lives when everything goes wrong. To make it out alive, survival has to be reframed from luck to procedural logic. This is the main thesis we really need to drive home today. The people who understand the physics of the disaster, how the ship displaces water, how their own body reacts to the cold, those are the ones who process the chaos through a lens of logic. They aren't just sitting around waiting for a miracle. They are calculating their next move based on the environment. And because they're using procedural logic instead of blind panic, they are for sure the most likely to walk away from the disaster.
So, here is your ultimate survival guide, drawn straight from our source material. Number 1, abandon the luck mindset entirely. It's a super dangerous myth. Number 2, understand water displacement. Know that when the air goes, the ship goes, so calculate your path against the water's entry. Number 3, anticipate the biology of hypothermia. You have to recognize that the dense, freezing air and that uncontrollable shivering mean you have a strict biological time limit. You need to conserve your heat and energy however you can. And finally, number 4, rely on procedural logic. When you actually bring the physics of the ship and the biology of your body together, you form a concrete, step-by-step procedure for survival. You are effectively replacing panic with a solid plan.
Which leaves us with one final provocative thought to ponder today. If the ship goes down, are you going to rely on luck, or will you follow the logic? Understanding the mechanics of our world isn't just about passing a science test. It's about being prepared for the absolute extremes. Take this procedural mindset with you, stay curious about how the world works, and always remember that logic is your absolute best lifeboat. Thanks for joining me on this explainer, and I will catch you next time.